when you are simplifying a rational expression, factoring is always the first step. Please highlight that on your paper. Would you turn to the back of your paper? There's some things about factoring that I need to make clear before we even start on any of these examples. So on this back half of your paper, would you write these examples down? You see how I have them divided into two parts. So these are rational because they're fractions. That's what rational means. It has fractions. Can I cancel like that? Is that good? And what's the answer? X divides into X one time, and then I have this 2 on the bottom. That's all good. Now, please notice that X goes into X one time, and that has a 1 in the numerator. Can I leave the 1 in the numerator out? Is it okay if I just write the answer like that? Is 2 the same as 1/2? No. You have to have the numerator. Now, if I had it the other way around, can I still cancel the X's? But what's the answer? 2 over 1, can I leave that 1 out? 1 divides into 2 times. Why is it okay to leave this 1 out and not that one? It means something different. This means 1 divided into 2. This means 2 divided into 1. Does it make any difference? Does it make a difference which way you divide? It sure does. So, over here, on this side, what about this? Is this okay? No. Got to make it totally clear in your mind that's not the same. Over here, canceling is dividing. That's X divided by 2X. That's 2 times X. Multiplying and dividing are all the same order of operation. So that's why it's okay to divide over here. Is dividing and adding the same level of order of operation? That's why it's not okay over here. But I'm going to help you understand this a little bit better. Over here, this canceling is not allowed because right here, I'm going to tell you about some special glue. Now, in my garage, I have some Gorilla Glue. You know what Gorilla Glue is? Gorilla Glue is what you use if you want to put something really glued together. It is even tougher than super glue. Well, we've got some glue right there. It's called adding glue. And adding glue is even stronger than Gorilla Glue. And there isn't anything that can break this adding glue. You cannot cancel these X's because they're glued together. By the way, subtracting glue down here is just as strong as adding glue up there. You can't cancel the X's here because this is held together by subtraction glue. Now, the real mathematical thing that's going on here is order of operation. But if you remember that these are glued together and they cannot be canceled, write that on your paper. Cannot cancel if we have the adding glue. You cannot cancel if you have the subtraction glue. But back over here on this other side, what if I have this? Anything cancel there? Since it's X plus 2 on top and X plus 2 on bottom, I can cancel the whole thing. But I just told you couldn't cancel if there was adding glue. But there's adding glue on both of them. So if you have the term that's the same, you can cancel the whole term. So this is when you can cancel, and this is when you cannot cancel. Got the difference? Because what we're going to be doing on the problems is we're going to be factoring and canceling. That's how you reduce. So if you will please go to problem number 1. Is there any adding or subtracting glue in there? No glue. So I can cancel and cancel all I want to. If you remember your exponent rules, here would be a good place to use them. If you don't remember your exponent rules, then you would have to expand all of those x's and y's. X to the third power, and y to the first power, and x to the seventh power, and y squared, and expand all those out. And then once you have it expanded out, this x cancels this x, these cancel, this y cancels that y, this y cancels that y. And one more thing, what about the whole numbers? Does 4 divide into 12? 4 divides into 12 3 times. Everything's been canceled that can cancel. What's left? On the top I have some y's. I have 2 y's, y squared. On the bottom I have a 3, and I have 1, 2, 3, 4 x's. That is simplified. So if you don't have any adding signs in there, you expand and you cancel out as much as you can. Example number 2, do we have some subtraction glue there? I can't cancel this x squared with that x squared. Because of that subtraction glue, that's not allowed. What I have to do is factor. Is there any number that divides both 8 and 2? And do you see that has some x's and that has some x's? They each have at least x squared or more. I'm just talking about the numerator. You do look at the numerator, you look at the denominator separately. So 8 divided by 2 is 4. X to the third divided by x is x minus 2 divided by 2 is 1. X squared divided by x squared is 1. Now, I'm going to look at the denominator. I have a 4, but the other one doesn't have a number. They both have an x. So I'm going to factor an x. If I take an x out of that, I have 4x left. I have a minus sign. X divided by x is 1. Now, in this part right here, is there any adding glue? Not in that part. So, this x will cancel one of those. This 4x minus 1 cancels that whole 4x minus 1. So, I have a 2x left. Now, what's coming up next is solving this. Isn't it going to be a lot easier to solve it from this form instead of that form and find out what x is equal to? So, we're reducing these, so in the next couple of lessons, we'll be able to solve it. The numerator has nothing to factor. Looking at the denominator, the 4 and the 20, 4 will factor out. Both of those have an x, so I'm going to factor out not only a 4, but a 4x. 4 divided by 4 is 1. X squared divided by x is x. It's got a minus sign. 20 divided by 4 is 5, and the x's cancel out. Is it okay to do that? What about the subtracting glue? Well, you're canceling out the whole subtraction and all of it. And so what's left? Is that the answer? This kind of problem was the most often missed problem on the test last year because that was the answer they told me. The 4x is in the denominator. So what goes in the numerator? X minus 5 divides into x minus 5 one time. Is 1 over 4x the same as 4x? No. You have to have the 1. Okay. What are we going to do with this? Well, what divides 9 and 36? 9. 9 divides into 36 4 times, and so I'm going to divide out a 9. X plus 4. Take the 9 out in front. Now, you can factor from this form, but it messes my brain up to try to factor that when the x squared is negative. I have terrible time with the signs. So if the x squared is negative, I factor out a -1 to make it positive. So I don't get my brain confused. And we usually write the x squared first, so I'm going to do that also. I'm going to take a -1 out of that and write the x squared first. I'm going to factor out a negative, and that makes this one a positive. When you factor out a -1, all it does is change the signs, and then it'll change the signs on that one. Now I need to factor a trinomial. This denominator has 3 terms. It's a trinomial. That's why you have that other piece of paper. That is your scratch paper. I didn't think there was enough room in your notes to get this all in your notes. So we need to factor out an x squared plus 2x minus 8. To factor that out, did I copy it down right? That's what I had, right? To factor that, I multiply the first term times the last term, and I write down the factors of 8. Since this is negative, I need the factors to have opposite signs, and I need them to add up to this number. So how can I put the signs over there so that they will have different signs and add up to that number? Will that do it? Since this is 1, I can use my shortcut factoring. This will factor into x minus 2, x plus 4. This will be x plus 4 on top. We have a -1 on bottom, and this factors into x minus 2, x plus 4. If you can fit it all in your notes, great, but that's what that extra piece of paper for is if there's not enough room. This cancels out. What's left? 9 on top. The -1 usually comes out in front as a negative sign. That would be the usual way to write that answer. Questions? Okay, on this one, I have a trinomial on top and a trinomial on the bottom. I'm going to have to factor both of those trinomials. Oh no, do you remember how to factor trinomials? So over here on your scratch piece of paper, x minus 12. The factor, this is first times last, -12. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. If this is negative, my signs on my terms have to be different. Which pair is going to add up to give me a positive 1x? If the signs are in there like that, does that add up to give me a positive 1x? Since this is 1, I can use my shortcut factoring. So back over here to my problem. I'm on the wrong problem. This is x minus 3x plus 4. Then I have my denominator, x squared plus 9x plus 20. Everything's positive, so that makes it a little bit easier. Can you factor that? The first term times the last term is 20. 1 and 20, 4 and 5 are the factors of 20. Which pair can add up to get a 9? So this factors into x plus 4, x plus 5. This factors into x plus 4, x plus 5. The x plus 4 cancels the x plus 4. And this is all that's left. Do you remember how to factor? Would you please complete the next problem for me? And that's what you get when you factor it. And next, you can cancel out the x plus 3's. I don't know why I canceled those, but anyway, that's fine. And so what's left over? That is your final answer. 6. 7 is a little bit more difficult. Do you know why 7 is a little bit more difficult? This number right here is not a 1. There is no GCF that factors out. So I just have to, this is going to be factor by grouping. Because this is not 1, you have to do factor by grouping. You still multiply the first term times the last term. Since that's a negative 4, the signs have to be different. How do the signs have to be so I can get a plus 3 out of this? Does that give me a plus 3? That 3 is replaced by this term because this term is equal to the 3. And then I bring down the 2x squared and the minus 2. The reason I replace the 3 is so I can have 4 terms so I can factor by grouping. What factors out of the first term? And what factors out of a 4 and a 2? When you factor out an x, the 2 stays and that reduces by an x. 1x divided by x is just 1. Factor out a 2. 4 divided by 2 is 2x. 2 divided by 2 is 1. If you've done this correctly, at this time you have a common term. The 2x minus 1 is the common term. See down there twice? X plus 2 is the next term. This gives you the x plus 2. That's just the numerator. You must also factor the denominator. So make sure I copied it down right, okay? And now the denominator is 2x squared minus 7x plus 3. When you multiply the first times the last number, it's equal to 6. The factors of 6 are 1 and 6, 2 and 3. This 6 is positive, so these have to have the same sign. What are the signs going to have to be so that I can have a negative 7? Will that give me a negative 7? The negative 7 is replaced with a negative 1x minus 6x so that I can factor by grouping. I need two groups of 2 to factor by grouping. What factors out of the first group? If this is negative, I need to factor out a negative, and 6 and 3 both divide by 3. If I divide an x out of that, I have a 2x minus 1. If I factor out a negative 3, that's going to give me a 2x, and that's going to give me a minus 1. 2x minus 1 is the common term. That's the second term. Two x minus 1, x minus 3. This is going to cancel. X plus 2 over x minus 3 is left. Remember that you need to factor first. The first thing I'm going to do in problem number 8 is to factor first. So what factors out of the numerator? A 9 and a 6 factors out of the denominator. Now, this is a pattern you're going to have to start learning to recognize. If this is a minus a perfect square number, if it is a binomial and it's minus a perfect square number, it's going to factor like this pattern over here that I have on the board to help you remember it. It's going to factor with a plus and a minus. How do I know 9 is a perfect square number? What is the square root of 9? Is it a whole number? That's a perfect square number. This 9 is out in front. This factors into x plus 3, x minus 3. This 6 is out in front. If you multiply the first number times the last number, you have a 9. The factors of 9 are 1 and 9 and 3 and 3. How are the signs going to have to be so that they would add up to get a negative 6? Does that add up to be a negative 6? So this is x minus 3, x minus 3. Does anything cancel? Anything else? What divides both 6 and 9? Is there any adding glue right here where the 6 and the 9 are? No. So 3 goes into this 2 times, 3 goes into that 3 times. Here is the final answer. Final, most reduced answer. Here is problem number 9, all worked out for you, so you can copy it down in your